Hi, it's my pleasure to introduce our first speaker today, which is Eben Lewis. Eben Lewis is the Southeast Regional Supervisor for the New Hampshire Department of Environmental Services Wetlands Bureau. Eben grew up in Mid-Coast, Maine, and earned a Bachelor's of Science degree in Wetlands Ecology at the University of Rhode Island. Eben has been with the New Hampshire Environmental Services since 2003. In his free time, he can be found in his habitat, the outdoors. Eben is an avid fly fisherman, a surf caster, turkey, duck, deer hunter, hiker, rower, and canoe paddler. It's my pleasure to introduce Eben Lewis today as he will present on New Hampshire coastal jurisdiction, tidal shoreline stabilization, and an overview of Env-Wt 600, the coastal wetland rules. Thank you.
Thank you, Marianne. Hi, good snowy morning and happy Friday, everyone. Thank you for attending our webinar today. This morning, I'll be speaking specifically about our tidal stabilization rules. Next. Today's agenda will cover three main areas: an overview, data screening, and standards. Next. The organizational structure of our rules has changed. The biggest changes are found in 300 through 600. 600 represents coastal resources expanded to include more robust coastal standards of 43 new pages. Next. Key sections of the title chapter are illustrated here. Next. The new definitions are added to increase clarity. Definitions are found in 5 locations, with the major definitions found in ENV 100. Next. The new rules contain over 100 new definitions, terms, and acronyms. Examples include PRA for priority resource areas and SPN for statutory permit by notification. Next. Another key threshold definition is priority resource area, or PRA. This definition groups existing rules, major resource areas such as protected species or habitats, and coastal resource areas. Our new resource is added through the new rules: floodplain wetlands contiguous to a Tier 3 or higher watercourse. Next. These 3 definitions are integral to the department's decisions for projects and tidal resources. Stephanie Giolongo will be reviewing the vulnerability assessment following a break after my presentation, and Mark West, West Environmental, will delve into the CFA after Stephanie. Next. DES's new Wetland Permitting Planning Tool, WPPT, is an online mapping program that provides important information to help the public and applicants plan their project. The WPPT provides access to data which can be used to avoid and minimize impacts to wetlands and other natural resources. The tool is intended to be used for screening purposes only, and it is not designed, nor does it have the accuracy to determine precise location of features or setbacks. In particular, the WPPT contains a coastal resource layer theme for tidal projects, enabling the user to review sea level rise scenarios, marsh migration, sand dunes, eelgrass beds, and property lines, to name a few. Next. 2 key terms are found in the existing rules have now been defined. These threshold terms are important themes that permeate the rules connecting the permit criteria, functional resource assessment, and impact assessment. Next. For any major or minor impact project that would impact tidal resources or tidal waters or associated sand dunes, the applicant will have to apply the results of the coastal functional assessment, select a location with the least impacting alternative to tidal resources and functions, and use on-site minimization measures and construction management practices. Next. Using the results of the coastal functional assessment, we've minimized our impacts and we get our CFA results. Next. Another great resource is our BMP manual created to assist the applicant in providing options about what techniques may be used to address avoidance and minimization for their project. Next. From the synthesis of the previous information, those factors are taken into consideration for the project. Next. So here's an overview of our tidal stabilization rules. The requirements are looking at the natural process functions, provide wildlife habitat, address known causes of erosion, avoid adverse impacts to nearshore ecosystems, processes, and habitats. And the criteria and design standards are a hierarchy of stabilization methods and analysis of existing conditions, techniques for stabilization, and living shorelines. Next. Many of the project categories have remained the same. We've included living shorelines. So previously with the old rules, minimum impact projects are repair work above the highest observable tide line, converting a hard structure to bioengineering, installing a new living shoreline exposed at high tide, and restoration work. Minor impact projects are new hard structures and increase of a hard structure. This is where coastal functional assessments required. And lastly is a major impact project. Those impacts within sand dunes, tidal wetlands, and undeveloped tidal buffer zone also requires the coastal functional assessment. Next. The stabilization hierarchy is established through the application and analysis of our rules. We consider what design is project appropriate. New Hampshire's coast is dynamic with many types of coastline, so the synthesis of all these references provided insight for suitable stabilization. Our new holistic approach for tidal projects to integrate and synthesize factors in consideration for these dynamic resources. Next. Oops, sorry, I got ahead of you there. That's animated. Next, please. Through a mosaic of tools and analysis, careful consideration is given to fully understand the project's juxtaposition to the other environs, structures, sea level, tide, and storm-related scenarios. Next. Vegetative stabilization via living shorelines is the preferred practice where appropriate. DES's definition mirrors NOAA and is similar to the Army Corps of Engineers. Next. The design stabilization techniques must address many factors. Another great desktop resource for analysis is the New Hampshire Living Shoreline Site Suitability Assessment, or L3SA. The L3SA evaluates living shoreline suitability using spatial data about the state's tidal shoreline and characteristics unique to the Northeast, such as a short growing season, effects of ice, nor'easters, and large tidal range. Next. Next again. The L3SA was published by the New Hampshire Coastal Program and is located on their website. The L3SA results are intended to inform a range of end users. The L3SA assigns a suitability index number between 1, less suitable, and 6, highly suitable, to points along the shoreline. Just like the Wetlands Permitting Planning tool, the L3SA is intended to be a screening tool used for planning purposes only, and sites of interest should be further evaluated with site-specific survey. Next. Salt marsh migration is another aspect to consider using the SLAM model via our permitting planning tool. The image on the left is of today. The image on the right is the 2025 marsh migration. Next. With the new rules, we also look at our existing structure conditions. What's the damage extent? Whether that existing structure has functioned as originally intended, and if there's any opportunities to soften the bank, and what's the ability of this structure to withstand coastal flood risk in accordance with the vulnerability assessment. Next. And of course, just as with the previous rules, existing riprap can be repaired. That's a minor impact, or excuse me, a minimum impact project. Next. So tidal stabilization using new hardscape or riprap typically is not approved by us unless the applicant can demonstrate that with these factors, it's the only approach that can be used. Typically, we also approve the use of riprap if it's a component of a sill to stabilize a living shoreline. Next. Due to the loss of the natural features such as habitat and the ability of a shoreline to move and adapt naturally to coastal hazard events that results from constructing a wall on tidal wetlands or waters, and due to the reflection and redirection of wave energy that can adversely affect surrounding properties and ecologies, walls can only be installed for public infrastructure projects. Next. As Kevin Lucy mentioned yesterday, DES has new criteria for our stream rules to account for bidirectional flow, storm surge elevation, and coastal resilience. Specifically, what we would be looking at are span structures in these tidal resources that are designed by a professional engineer, can meet a 100-year storm, also meet the general design criteria for stream rules, and also require a functional assessment and a vulnerability assessment. Next. Oh, sorry about that.
Are you set, Devin?
Oops, sorry about that. I actually hit my microphone. Yeah. If
Do you
anyone
have
has any questions, and fire away.
So there's one question here. It says, and I think I'm going to answer this if that's okay. It says, should a length of a road be abandoned, will waiving permit fees for permanent disturbance be waived, or at least considered for future policy? So the fees are set by statute, and so the department does not have the authority to waive that. There is a rules waiver process that has to be consistent with the statute and rules in ENV-W2 200. Are there any other questions for Evan based on his presentation today? Oh, let's see, hold on. Here's another question. So there was a question about the PDFs, and I think our business analyst has answered that, and that's in the chat. Here's another question. We are recording the sessions. We'll be distributing all the information to attendees after the presentation. So here's another question. Is there a coordination between New Hampshire and adjacent states such as Maine, which have far more extensive tidal shorelines that are ecologically contiguous and relevant? Evan, do you want to answer that, or should I answer that?
I know from the perspective of beach management, there's coordination between the states. That's about the extent I'm aware of. I don't know if you can speak.
Yeah, so I know there's the coast of Maine. I can't remember the name of there's a bay, coastal Maine Bay interstate group that our coastal program manager, Steve Kuchar, participates in. And so I think there is coordination between the states. DES also participates in the New England Wetlands Work Group, which I am a representative. Lori Summer is a representative, and we do hear from all the New England states on the latest happenings. So there is coordination, but it's a good suggestion to consider for future enhanced communications. Are there any other questions? Let's see. Please send the reg that indicates the coastal functional assessment is not required. It does not work in previously developed tidal buffer zone. Can you respond? I can't totally understand that question. Can you, what? Doesn't include work in the previously developed tidal buffer zone. Can you respond to that, Eben?
If the work isn't in the tidal buffer zone, previously developed tidal buffer zone, or any tidal resource, then it wouldn't require the vulnerability assessment or the coastal functional assessment. The only areas where those two assessments would be required are in our jurisdiction, which would be the previously developed tidal buffer zone and undeveloped tidal buffer zone and tidal resources. And most notably, the vulnerability assessments required for all projects and tidal resources, whereas the coastal functional assessments only required for minor and major impact projects.
That's right. So I don't see any other questions in the chat. So our next presentation, we can start a little early, and that's for Steph Giolongo. Is the coastal permitting specialist for the New Hampshire DES Wetlands Bureau. Stephanie grew up in southern New Hampshire and earned her Bachelor's of Science in Freshwater Ecology at Western Washington University. Upon returning to New England, she worked for NOAA in the offshore commercial scallop industry, then completed her master's at UNH in civil and environmental engineering. Stephanie has been at DES since 2014, sorry, talking about myself. Outside of work, Stephanie enjoys paddling, fishing, crafting, and walking in the woods with her dog, Olive. It's a pleasure for me to introduce Stephanie, who will present on coastal vulnerability assessments as required by the NHDES Wetlands rules. Thank you, Stephanie.
Steph, just to let you know, you're muted if you're beginning your presentation.
Thank you. Okay, now everybody can hear me, right?
That's correct. Sorry about that, Steph. I had muted you.
Thank you. Okay, so welcome everybody to day 2. I'm going to be talking about the Coastal Vulnerability Assessment per Env-Wt 60305. I think you'll find, I believe most of you were in attendance yesterday. I think you'll find that this presentation will dovetail nicely with Natalie Morrison's from yesterday. Natalie covered the vulnerability and assessment and risk tolerance from the perspective of the coastal flood risks and guidance document. This will be a presentation on vulnerability assessments from the perspectives of the actual wetlands rules. So I'm going to quickly recap the general concepts of vulnerability and risk tolerance. I'm going to dive into the step-by-step process outlined in the rule, and then share a few additional resources that might be helpful as you complete your own vulnerability assessments. So what is vulnerability? It is the likelihood that an asset will experience harm due to exposure to coastal hazards. Vulnerability is a combination of the asset's exposure to coastal hazards, its sensitivity to inundation, and its adaptive capacity or resilience in the face of coastal flooding, sea level rise, and climate change. Tolerance for flood risk is a project or an asset's willingness to accept a higher or lower probability of flooding impacts. So assets or projects with low tolerance for flood risk include critical transportation infrastructure, valuable historic sites, essential habitats, or assets or projects that are expensive and have a high cost of replacement. So those types of projects or assets should be planned, designed, and constructed using higher coastal flood risk projections. That compared to assets or projects with a high tolerance for flood risk, such as sheds, pathways, small docks, things that are generally less expensive or easier to replace, or less critical to public safety. Those types of projects or assets have the option to be planned, designed, and constructed for a less protective coastal flood risk projection. So jumping into the rule, Env-Wt 60305, as Eben just alluded to, these vulnerability assessments are required for all projects in coastal areas. So any project, that is subject to Chapter 600 requires a vulnerability assessment. So first, the rule follows this stepwise process that's very similar to the one Natalie went through yesterday, a little bit less detailed, but starting with determining the time period of your project or your asset. So over what period of time do you expect your project to last? This rule actually currently specifies the design life of the project. The coastal guidance document that Natalie spoke to yesterday puts more emphasis on the useful life of the project. So just real quick, useful life assumes that there's regular maintenance of your project or asset over time. So it typically exceeds the design life. Just something to consider. After determining the time period, you'll want to identify its tolerance for flood risk. So again, projects with a high tolerance for risk have a low value or cost of replacement. They may be easily modified or have a low sensitivity to inundation. Versus assets or projects with a low or extremely low tolerance to flood risk, which are going to be expensive or extremely critical to public safety or transportation infrastructure. Following that, you'll want to take that information and assess the projected sea level rise that most closely matches the time period and risk tolerance that you've selected from the first 2 steps. So this chart probably looks familiar. It's from the Part 1 presentation yesterday, the science behind coastal flood risks and sea level rise in New Hampshire. You can see that the blue shaded area indicates the range of most likely sea level rise scenarios. and they go up from there based on the range of estimates and global greenhouse gas concentration scenarios. So kind of tying it together, lower projects with a lower tolerance to flood risk, meaning those more critical infrastructure, critical to public safety, higher cost of replacement, you may want to consider a more conservative sea level rise projection that's going to have actually a higher estimate of projected sea level rise to ensure that your project is planned, designed, and constructed appropriately in the face of that scenario. So with that information, you'll also want to look at your project in the context of the landscape in your site and identify areas on your site that will be subject to flooding from that sea level rise scenario, and areas which are currently located within the 100-year floodplain and subject to coastal flood risk. So these images show first the current day mean higher high water boundary outlined in the purple there, shaded in filled with the blue. This is the 2-foot relative sea level rise scenario without storm surge, and the 2-foot sea level rise scenario in the event of a 100-year storm event. So it's important to kind of take the scenario and consider the time period and the risk tolerance and the sea level rise projection, and step back and view your site from this type of perspective. And with that information, you want to put that onto your project plans that are submitted with part of your wetlands permit application, and identify the areas on the site relative to the location of your asset that may be inundated under that selected sea level rise scenario. So when you go through that stepwise process, you might realize that your asset would be inundated under the anticipated scenario. And if there's a conflict, then the rule requires a pre-application meeting. So we would meet with the applicant, your client maybe, and discuss what alternatives might exist for designing the least impacting alternative to the resource and accounting for the appropriate sea level rise projection. So the rule requires this vulnerability assessment, and among other things, as Eben described, there's a list of different types of requirements for different project types in coastal areas. So the Wetlands Bureau has created this coastal resources worksheet. It includes guidance and reference for all of those different project types: tidal docks, shoreline stabilization, sand dunes, but also provides a general outline for compiling the information that's required for an application for a wetlands permit in a coastal area, including Section 4 for vulnerability assessments. This worksheet basically just outlines those steps, gives you a short text box, and I've found that it's generally appropriate for projects that are truly least vulnerable to predicted sea level rise, or those with the highest tolerance for flood risk. So landscaping projects in tidal buffer zones, or buried infrastructure that has a low sensitivity to inundation. And the form kind of gives you that rough outline to run through the steps and provide a basic analysis. Sometimes for certain projects, that isn't quite enough. There needs to be more detailed, or if it's a more complex project, maybe you have multiple features, multiple assets on the site that have varying degrees of sensitivity or risk tolerance. And in those cases, it's been found through the past year of reviewing these applications with vulnerability assessments that a standalone type of more thorough assessment, a narrative style report, is more appropriate to complete your vulnerability assessment. It's the same stepwise process, but just outside of the framework of the Coastal Resources Worksheet, it allows you more flexibility to describe and articulate the different variations or the range or the unique aspects of your project or your site. So shoreline stabilization efforts or Tier 4 stream crossings, those are the types of projects that likely require a more of a free form or elaborate articulated vulnerability assessment. And just to note too, the coastal resources worksheet is not required as part of the wetlands permit application. It's provided as a guidance document and really lays out an outline for what you could compile in a standalone document like this. So we've been reviewing these applications for a little over a year since the new rules went into effect in December 2019. And these two general take-home points are what I've gathered, and Eben and I, who've been reviewing most of the coastal wetlands permit applications, are that the vulnerability assessments are incomplete. They should be more thorough than just simply checking the boxes or filling in one line or one word answers on down the coastal resources worksheet. There needs to be some level of analysis and thought process put into it. Also, vulnerability assessments should be proportionate to the project. So that's what I was trying to describe, where if it's simple project, low risk tolerance, and can really be captured in just that stepwise coastal resources worksheet, that's fine. But for a project that is more complex or is more sensitive, that's going to require a more robust assessment, more thorough analysis. So from your perspectives as you're completing your wetlands permit application, this is something that tends to cause delays in the process, where if this information is planned out and provided up front, it just streamlines the process and makes for a smoother review and permitting process. So some additional resources that you heard a lot about yesterday that are extremely valuable and informative to a vulnerability assessment would be this New Hampshire Coastal Flood Risk Summary. There's part 1, the science, part 2, the guidance document. Both were covered yesterday and tie really well into what I'm talking about right now. There's the New Hampshire Coastal Viewer. It includes all of the information on tidal stream crossings. It has the sea level rise estimates and projections, the marsh migration scenarios, and the New Hampshire Coastal Program themselves. All excellent resources. So in summary, I've recapped on vulnerability and risk tolerance, gone through the stepwise process outlined in the rule, and shared those few additional resources. If you have any questions, I'll take them now.
Thank you, Stephanie. Great job. So there are some questions here. One question is, do projects have to follow current setbacks, or do they have to be set back from future limits?
I mean, if you can clarify setbacks, I mean, in any case, the setback would be applicable to the existing condition. So,
Yeah, or the time the application was filed. So when the activity took place, that's right. Yeah, or what? Yeah, and the existing condition. All right, that is kind of vague. I agree. We could have some clarity on that question. That would help. Another question is, if you have an existing residential structure that is submitting a permit application for repair, but would be inundated under the 2-foot rise, what would DES recommend where the existing structure cannot be changed?
I think that gets into the complicated and difficult discussions that were alluded to yesterday, where, you know, at a bare minimum, this process forces a landowner to realize that and to see that this is, you know, a probable projected scenario, and that's a difficult question to answer. I mean, obviously, nobody wants their house to be inundated, but the science is showing that that's probable.
Yeah, that's an excellent question. I know we, the program here had a training from the Office of Strategic Initiative on the new FEMA coastal maps that have just been released. And that was, there are requirements in the 100-year floodplain that have to be met as well for insurance purposes. And so all these questions tie together. So I think that is a challenging issue. That's correct. Another question here is, does the WPPT, the Wetland Permit Planning Tool that Evan Lewis talked about, and Steph, you led the development of, have sea level rise scenarios and salt marsh migration layers? Has there been or will there be WPPT training?
There have been workshops and presentations on the permit planning tool. If you had specific questions, or if you'd like just a run through, I'd be happy to provide that. So yeah, they do include those layers. There is a guidance document that actually, I believe at this moment the link to is broken after our new website has gone up, but that's something I've been working on restoring. And yeah, again, you can feel free to reach out to me directly. I'd be happy to speak to any details or provide any specific
Yeah.
guidance on that.
Thank you, Steph. Yeah, that was.
Can I speak real quick to the previous question too?
Yes, please.
As much as the broad picture, that's a difficult question to answer. I think there are adaptive measures that can be considered. So more specifically to a house being inundated under the 2100 sea level rise projection, there are design BMPs that certain people have employed in other places that, to elevate the house or change the way it's constructed so that it would be more resilient in the event of an inundation or flooding event. So I just want to kind of clarify that it's not to be so vague, but there may be certain things or BMPs that could be employed as more of an adaptive strategy for resilience.
That's an excellent point, Stephanie. Thanks for bringing that out. I think some of that is mentioned in the guidance that UNH produced as well. I've seen some adaptive measure suggestions in there. And I just like to point out that Stephanie has done numerous trainings on the WPPT, everything from the wetland scientists to conservation commissions, and published an article in the municipal guide. It's been very well received, and we're excited that folks are starting to really get to use that. Let's see, there's another question. Do you have any vulnerability assessments that are complete that could be shared with the public as an example? Or is there time today that you could go through an assessment during a presentation like this that would be helpful?
I do have some examples. Over the past year or so, some consultants have reached out for examples, understandably. And I'd be happy to do that. It's a little bit challenging because we've only been doing this for a year, and quite honestly, there's only a handful of you guys, of consultants out there that are doing these. So it's sort of limited in the range and breadth of assessments that we've seen. So I'd be happy to provide some specific examples or to speak more specifically to those areas that are sometimes kind of that miss the mark on specificity or thoroughness. But those were the general kind of concepts that I've captured reviewing these assessments. It's hard to identify specifics. I don't want to point anybody out, and there's only a handful of people who are doing these. So please, again, feel free to reach out to me directly. I don't think we'll be getting into much more detail on these in the workshop today. I would point you to Natalie's presentation yesterday. That was extremely thorough and very well done. It is in greater detail than the actual wetlands rule gets into, but it is the concept that we're hoping to capture. So I would encourage you to take another look at that too, where she goes through step by step.
All right, so we have 3 more questions here that we can take. 2 from Galen Peresa, I'm not sure I'm saying his name. He says there is a FEMA brick funding for elevating houses, but it needs to be applied on a community level. And then he also asks, since the assessments are so new, can you give a general estimate of the time required to perform one of these assessments?
Sure, the vulnerability assessments, I think, again, it would scale based on the complexity and the nature of the project. But with the information, you know, if say you were to use the New Hampshire coastal flood risk guidance, that's all, you know, basically at your fingertips. And then the time required to assess the vulnerability of a site is one thing, but then you'd want to be assessing the vulnerability of your design also. So I think the time would be spent on designing your project or your asset to accommodate or, you know, to address the scenarios that you've selected. So going through the steps, choosing the time period, assessing the relative tolerance to flood risk, and then applying the scenarios that fit those 2 parameters, that shouldn't take very long, maybe a couple hours to read through the materials, but mostly desktop, I guess. But then looking at your specific project or your asset, that's where sort of the creativity or the real thorough analysis is going to have to come in. And how can you make your project most resilient when you consider those scenarios of sea level rise and tolerance to flood risk? So I don't know how long it would exactly take. I would imagine, you know, just to put a number, a few hours.
Yeah, and I think it would depend on the skills and experience of the person doing the assessment. Hopefully, as more people are getting these done in a complete and acceptable way, that will become more efficient. And I think you raised a great point about the complexity and the nature of the assessment overall. So there's another question here. It says, if the house is elevated, how do you still have a working septic system?
Well, that would be an engineering and design question. That's beyond the scope of my expertise. I would imagine you may need a pump.
Yeah, and maybe the Subsurface Systems Bureau can answer that question at DES, Rob Tardif. I would follow up with him. I think that's appropriate. Are there any other questions that we can answer here today? There was one question yesterday that we didn't answer that I can touch on before we go to the break. There was a question about the public-private boundary. And so generally that's dictated by New Hampshire case law, and the public trust boundary does change to match long-term changes like accretion and erosion. There may be, so if there's a sudden change, short-term change, it does not change the boundary, but if it's a long-term change, it would. However, I would encourage you to do your own legal research. This is something that other states may have cases on this topic that could further advise you on the public trust private boundary. Let's see, we have 3 more minutes. What was another question? I think we already, the permitting costs be waived. The department does, we have issued some waivers for delineations, which is required by rule, where the impact is very small and the site may be very large. And the Army Corps does mention that in the general permit as well. But the statutory fee requirements cannot be waived. It will be set by DES waiver rules. I think that's all we have time for now, unless there are any other, let's see, there's one more question here. The guidance for tolerance to flood risk in UNH report and your presentation is extremely helpful. but in determining TFR always going to be somewhat subjective. Can you respond to that, Stephanie? Not sure what TFR is. Do you know what that is?
No, I don't offhand.
That's tolerance for flood risk.
Oh, okay. Could you repeat the question for me, please?
All right, I'll try. It says the guidance for tolerance to flood risk in the UNH report, and your presentation is extremely helpful. But in determining TFR, is determining TFR always going to be somewhat subjective?
Certainly. I mean, I think some assets are more straightforward than others. If, you know, from a public safety standpoint, if that is a major transportation corridor or a critical public safety facility, then that's obviously, you know, high value and low sensitivity to inundation, and high cost of replacement. So that seems pretty straightforward. But when you get to other structures that may be, you know, relatively expensive, like I imagine tidal docking structures, but from a public safety standpoint, that it gets, you know, more subjective, where the owner may place a higher value, but in terms of public safety, it may be less. So it is subjective.
So
And
the rules are based on standards. You know, there are objective standards in the rules, and that's why we reference the UNH guidance. There's been a lot of collaboration with transportation professionals, engineers, scientists, and social scientists. As Stephanie indicated, if there is a conflict, engineering solutions can be discussed in a pre-application meeting. If you cannot resolve these conflicts, so I think that it is relative, but it's based on science, projections, and all the information that's brought forward as part of your application with the applicant's objectives, any conflicts, and all those items are set out in the more robust coastal rules. Let's see, we're almost at the break time. So it's 10 o'clock. We'll have to answer that question later. So I want to honor everyone's time. So we'll have a break from 10 o'clock to 10:20. Thank you for your excellent discussion. And our next speaker will start at 10:20 sharp. Thank you very much. What?
Marianne and Tom, can you hear me?
Yes, Cheryl. And you're live to the entire session.
Everyone can hear you, yeah?
Could you a second, or just someone say something?
Hi, we're almost ready to start our next session after the break. I hope everyone's getting ready.
I'm excited.
Thank
Good,
you.
I'm
I
glad
had
to hear you,
to
Mark.
switch. My headphones turned off, so my computer wasn't hooking up to them, but now it sounds like I'm
Okay,
back on.
all right, so we're ready to roll. We're ready to roll, Tom? Mark?
I'm ready on my end.
Okay, good.
Ready.
Excellent. Thank you for returning for session 2. We can see we have 102 attendees right now, which we're excited about and hope that you're getting as much out of it as we are. So our next presenter is Mark West. Mark West is a New Hampshire certified wetland scientist and a qualified wildlife biologist who started West Environmental Inc. in 1998. He's been working in the field of wetland science for over 34 years and has mapped and evaluated thousands of wetlands in New Hampshire, Maine, and Massachusetts. He has served as chair of his local conservation commission in Nottingham, has served on the board of Bear Paw Regional Greenways, a land trust in northern Rockingham County, and has been an adjunct professor at Antioch, New England Graduate School. He brings his extensive experience to projects ranging from wetland permitting to arms studies to municipal review and threatened and endangered wildlife habitat assessments. He lives on his farm in Nottingham and coaches ultimate frisbee at the Oyster River High School. It's my pleasure to introduce Mark West, who will present on coastal functional assessments as required by the DES Wetlands rules. Thank you, Mark.
Thank you very much. And good morning to everybody. I guess I want to start by saying, having attended yesterday, a lot of the things that we as wetland scientists see in the field are being supported by all the predictions and current changes in coastal wetlands and freshwater wetlands on the seacoast. Over the years, I've gone back to delineate flagging that I had done on tidal wetlands, 10 years earlier, and the tidal boundary has gone upslope. The trees are dead along the shoreline. Almost always, there's changes to that tidal wetland boundary, and so we've seen the changes, and it's only making more wetlands, more freshwater wetlands from the groundwater level rise on the coast, and I guess ultimately even more work. Next slide. So coastal resources are very diverse, and some of the techniques we use for functional assessment, like the highway methodology, don't really apply to things like dunes or ocean shore and things like that. So the first thing we have to understand is, as certified wetland scientists are qualified for delineating wetland boundaries, but most wetland scientists need experience and have worked on dunes and seacoast permitting in order to really understand how to do a functional assessment of them. Next slide. What I'm going to talk about in addition to in my talk is the coastal functional assessments, the methodologies, and discuss some example projects and spend a fair amount of time on minimization. But coastal projects are very diverse because the resource is diverse. So a wetland scientist can end up doing permitting on things like seawalls that continue to get damaged and last sometimes less than a year before another storm surge pulls rocks off the wall and repairs need to occur. So you've got the tidal buffer zones, you've got bank stabilization, seawalls, dune impacts, salt marsh impacts, and really that the diversity of resource area and the diversity of projects gives you a wide range of information that you need to collect when you're doing these projects. Next slide. Stephanie was just talking about this and the need for complete and accurate information. They need clear and detailed plans. More and more, we're going to color plans. So it's very clear what is happening on the site and proposed on the site. Accurate resource assessments, aerial and on the ground photos. Photo documentation is key for them to see because not all projects get inspected. And aerial photos are key to give them landscape context. Coordination with natural heritage and fish and game. This is now an upfront issue, whereas before it was during the permitting, and it can take a month to sort things out. And so that coordination is key. It's our job as the consultants to do that. Documenting the minimization measures, not just checking off and saying we've minimized, but explaining how we've minimized the project. And this sometimes is the biggest key to all permitting. Detailed construction sequencing. They need to know what's happening start to finish. Restoration plans for temporary impacts are required and need details, and monitoring as needed. And so we'll talk about those in each project example. Next slide. So this is the Coastal Functional Assessment Worksheet section. In addition to the wetland evaluation, and Eben has patiently asked for a lot of this, sometimes that hasn't come in and needs an RFMI, is these other issues related to currents, beach and tidal sediment replenishment, movement of sediments. This is where Eben said sea walls are only allowed for public projects. Because of their big impact to wave energy and changing that. And then things like project runoff to salinity levels. All of that's required for all of these projects and needs to be considered with the functional assessment. Next slide. So this just lists the rule on the sheet, and you'll see it says highway methodology, and then it also says an alternative scientifically supported method with references. I've had to do this, and I'm going to discuss why sometimes the highway methodology isn't, well, it's not the right evaluation for dunes and may not be the right way to evaluate certain parts of tidal wetlands. Next slide. So this is, some of these slides are from Mary Ann, so she gets co-producer credits, and these are just what the functional assessment rules require, and then you have a qualified coastal professional, which I guess I'm one of those. That little area on the right My concern is that crazy picture with all the words is what somebody is thinking when they're reviewing the final product. So the goal is not to confuse, but to clarify when it comes to functional assessments. Next slide. So this is just a run through of a highway methodology with the little pictures. Believe it or not, in 1999, or it may have been even earlier, I did presentations with the Corps of Engineers and the EPA on how you do this methodology. And it's got some good points, but it also has some weaknesses, and we'll talk about those. Next. So these are the functions in the rules. They sort of tied it to the highway methodology, but also included some other things like ecological integrity, which the New Hampshire method has, and which on some projects I do the separate ecological integrity assessment through the New Hampshire method with the rest of the functional assessment. And we'll go to the next slide to talk about things. My concern is, in addition to the first few sheets, which talk about the size of the wetland, the size of the watershed, this is the result of a highway methodology. My concern is that a conservation commissioner is not going to know what all those numbers mean. You do have room for some notes, but not a lot of room. And so this sometimes, always, in my opinion, needs an explanation in a narrative form so that they understand. You can see those boxes that say suitability. In other words, is the function present? But then also, is it a principal function? That decision about a principal function is a subjective assessment based on the wetland scientists' experience and comparison of that wetland with all the other wetlands they've evaluated, or with all the wetlands that might be in that town. So that's where you need some explanation, as you can see. Next slide. What I've done, I did this years ago, is I've taken for tidal wetlands, and I'm going to be using this more now that the rules require it, is a sheet. It's actually 2 full pages, but it basically tells people what kind of system it is, what is present within the wetland, and understanding how those systems work. So it starts with identifying the type of wetland. And I noticed Kevin Lucy in his document, they've cross-referenced it with the Nature of New Hampshire and Dan Sperduto's and Bill Nichols' work. That can be done also. This is sort of a hybrid of that. But you start with what kind of system it is, and it mostly has to do with the plant community and landscape position. Next slide. Then you talk about ecological integrity. This is important in understanding what's going on in that salt marsh and potentially in the buffers. You can see in the distance in the back of that photo a ditch, and most salt marshes have all sorts of ditch systems, and that's part of understanding the ecology and the integrity of the marsh. But if you answer these questions and they're on a sheet, a couple pages, there's a lot of information that can be prepared to understand what's going on in that wetland from an ecological integrity perspective. Next slide. These are just a breakdown, a simple, quick and dirty discussion of functions. Shoreline anchoring is key in a lot of tidal systems, and we sort of start to get into the structure and the type of system. Then in flood flow alteration, sometimes the size of the wetland is not as important as its position. And then what is this exposed to? And again, we'll look at some examples. Then you have finfish and shellfish habitat and some of the systems associated with that. Next slide. And then here's some more function: water quality maintenance, recreation, education potential, and noteworthiness. Education potential is one of those things that I worry about, is mostly focused on really systems that have more public access or adjacent to public right-of-ways, and also have access for school kids. So that's a very specific condition, but it's one that's in the rules. I like the beautiful picture of the salt marsh. It's almost like a work of art. And this is why aerial photos should be with every application. Where is your project in the landscape? Next slide. Wildlife habitat, I think I start by looking at critical habitat, if it's present, what the features are, the species specific information, and this should be done for any habitat. And again, all of these slides I've just shown all can be on one 2-page document where they can look through and understand everything. A lot of the critical habitat, wildlife habitat ones I have typically done off the coast are more like Blanding's turtles. And is there deep marsh habitat? Are there loafing logs for turtles? So that's where you break down the species and then the physical features. But we also look at all kinds of other things, specifically connectivity, diversity, and then habitat degradation. The habitat degradation is critical in understanding a lot of the buffer zone projects. Next slide. So in every application I do, the minor and major, I do a wetland assessment report. It includes all these components because you don't want to just tell them what the function is if they don't know what's the plant community, the soil, the hydrology, what sort of wildlife did you observe. That's important information that goes into the functional assessment. And you describe the functional assessment, and then you explain the principal functions and the functions present. And then you do the work that's most critical to almost every project, which is the avoidance and minimization. And then I include a section on wetland impact assessment and mitigation. This is all in one narrative report. However, I also, with every application, list every document included so that you want to have the avoidance and minimization narrative form, because the intake people at DES don't know if you did avoidance and minimization unless you have the form. So I'm now, some of these applications have 30 attachments. So the DES, there is a lot more work to answer all the questions and to provide a complete assessment. Next slide. So this is my first example. We're at the mouth of the Lamprey River, and just downstream to the bottom of it goes right into Great Bay, and it's tidal here. These two houses had two tidal buffer zone projects, and I want to just show what they look like and some plans and things like that. So even though it doesn't look like it, right where you see 19 on Moody Point, there's a fringe riverside tidal wetland that is adjacent to what you can see is a pretty wooded buffer on 19 Moody Point, and then a narrower buffer and a lot more lawn on 17 Moody Point. Next slide. This is not to scare you, but this is what some of the permit plans now look like when you combine tidal buffer zone when you combine shoreland, when you combine local buffer setbacks, when you have temporary setbacks, when you have impervious versus pervious setbacks. So this is what we mean by detailed plans. And nowadays, this is a couple years old, I would go color with some of this because it's just so complicated. So in this particular project, even most of the work was all tidal buffer zone. There was 2,400 square of temporary impacts, mostly to replace a septic system in front of the house with a septic system way in the top left-hand corner, and to move that septic system well away from the tidal wetland. And so the permanent impacts in the tidal buffer zone for this project were 57 square feet, right on the very corner of the very front edge of the house. But there's a lot of impacts here and a lot of explaining to do and a lot of details. Fortunately, there you can see all the trees were picked up, and there's a nice tree line right along the tidal wetland. Next slide. So this is what it looks like. I'm standing at the edge of the house, and nothing's happening from there all the way to the tidal buffer. And Mel Proskoff, who's a brain surgeon, and believe me, they are very smart, but very intense. He keeps saying he's going to get this project done before he dies because it's taken several years. But even though we're way away from the resource area, we are planting some shrubs right along next to the house, some native shrubs, to create a little bit more habitat and a little bit more protection and reduced lawn adjacent to the tidal wetland. Next slide. So this is the house next door. So where the north arrow is where Mel's house is, and this is Steve Breaker's house. And you can see we've gone to color. You can see the steep slope along the river. And this project, that little area in red, is the only permanent impact. The new permanent impact is 14 square feet. And I know you'd say, well, why don't we try to get rid of that? But the blue area, he's removing existing structure, 48 square feet. There's temporary impacts of 119 square feet, but then there's all the shoreland impact and other impacts. But the difference is, look at all that woodland between the house and the river. Next slide. This is the tidal wetland. So because there's a salt marsh, anything within 50 feet impacts what you do on this project and would kick it out of minimum impact if you were working. But also, let's talk about the functions of this wetland. Flood storage, it's right along the Lamprey River. We're looking upstream. So clearly it has flood storage. Shoreline anchoring or stabilization, key. As with a lot of locations, you can see some stone right along that shoreline. And there's stone walls and some shale and stuff that's exposed, but that helps stabilize that shoreline. It has ecological integrity. Look at the landscape position. It has fish and shellfish habitat. I actually saw a lamprey. I had a picture of it. I should have added. In the Lamprey River. It swam right up to me. It has water quality protection from any runoff coming along the shore. It's noteworthy. It's right at the mouth of the Lamprey River. It has rare species in the Lamprey River. But in this case, when you look at those impacts and the explanation I gave to the Natural Heritage, they said even though there's rare species, we don't think there's going to be an impact. And this is also a designated river, which makes it noteworthy. And then, of course, it has wildlife habitat. They have bald eagles that land along the shore, great blue herons, waterfowl. So we know the importance of this resource area. Next slide. This is the buffer. So when you have a buffer like this and you're not cutting a single tree down, you are doing your minimization, but you still need to spell it all out. Next slide. So we're on to a bank stabilization project in Newington on the shores of Little Bay. I apologize for being so zoomed out. All the work is right along that shoreline. But the biggest issue with this project, where you see a building below the north arrow, that's a house and a shed, you see the incredibly steep slopes, and that is the only place where they can access. And as a matter of fact, the neighbors needed access and use this. And this project was part of several houses that were doing bank stabilization. So as one neighbor did it, the others said, well, we should tie in, and it becomes more of a piece by piece project where people want to do these projects. We have a very steep eroding bank. Next slide. This is what the shoreland looks like. The house is up over the hill. You actually might, well, you can kind of see the roof line right at the ground level at the very top of the photo. But this is an ongoing erosion problem. It's not going to go away, and it's definitely makes sense to try to stabilize. What Eben talked about in his talk is we have that lower 10 to 12 feet is the zone, or 20 feet to the right side photo is the zone where the impact is, and we really need a hard sill that we can build on then, and then use soft stabilization after that. So this is the situation, and it really needs to utilize some hard stabilization with the soft. So the next slide shows two big issues. The first issue is that access. That neighbor's house is snugged right up, and their shed is snugged right up on the property boundary, and they have foundation drains directing water to this slope, and this is the only way to get down to the beach. And so you have the access and mobilization. All of this sequence stuff needed to be spelled out, how it's going to be done, where it's going to be done, what the temporary impacts are, how they're going to be restored. And the next slide to the right is, yeah, stay on this, is the yellow is one of those booms. The rocks are what are going to be used, but the rocks were laid out and a little depression was dug out in the beach. It's all temporary impact area. On this project, there is 1,500 square feet of temporary impact, and you're looking at all of it in this photo, and only 75 feet of permanent impact, and then you've got your other impacts to the tidal buffer zone, 1,900, and then so this little depression was a trap for anything washing down on that slope on the left side that then could be graded out. This is all beached, it's not vegetated, but it's all a tidal resource. Next slide. So to the left is what the shoreline looks like. I have a contractor I work with who is a nut about large stone. He loves the bigger the rocks, the longer they're going to stay, the more coastal resilience they'll have, the less vulnerable they'll be. And so this may look like overkill, but 20 years from now, it's going to be more than appropriate. And so this is about exactly what these rules and what everyone was talking about yesterday is building to the future to protect for the vulnerability, for the sea level rise, for the storm events, et cetera, et cetera. These coastlines do not get hit as hard as, of course, those Atlantic Ocean ones. So I don't think this one on the left is going to need a lot of maintenance for many years, unlike the Atlantic Ocean ones. But building it strong and large will be better. And then above that, we had the matting, of course, the wildlife friendly matting, and then the seeding vegetation. And this was right after it was built. He is planting some small trees in here to extra stabilize it. I haven't been back there in a while, but I believe we're going to be submitting a follow-up report. On the right side is the protection of that slope. So originally he was going to build a wooden dock out over the wall, not a wooden dock, like a wooden, because he had a wooden structure out there, a wooden walkway out to like what would be like a little raised area. And Anthony, the contractor, convinced him to go with stone steps. These are much more able to be long lasting. And then above that is seeded areas, but also stone swales to handle the runoff from the drains that outlet that. And I think I might be running low on time. Am I supposed to go to 10:50? Anyway,
Yep, that's correct. Yep, it is. Your time is gone beyond. Are you going to be winding up soon?
I am right now. Sorry. Next slide. Real quick, dunes. We talked about the fact that dunes do not fit into the highway methodology. So I tried to come up with a functional assessment. I'm working with, hoping the UNH coastal program can help us with this. So this is the dune assessment. We're looking at density, diversity, rare plants, invasive plants, threatened species, slope, stability. Next slide. Obviously, wildlife habitat. Some of the functions we're looking at are storm surge protection habitat, rare species habitat, sand and sediment stabilization, and rare plant habitat and scenic quality. Next slide. This is just a picture of dunes. Next slide. This is just the back dune, which is much more diverse with a maritime forest, things like Hudsonia or heather, all mixed in. So this would be considered extremely diverse dune habitat. Next slide. Here's a typical dune project. There's a house, there's concrete areas, there's a lot of disturbed dune in front of the house. Next slide. These are the kind of details we do now. Dune impact, dune grading, temporary impacts, dune creation or restoration, and enhancement areas. Next slide. This is typically what a lot of the projects look like. You can see the dune doesn't have much vegetation. You've got patios and things like that. So what we do is remove things and restore them. Next slide. This is the actual impact area where we had field wormwood, a rare species. So we had to flag each species. Then we had to actually do the transplant of each species. We had to have a watering plan. All of this had to be worked out with Amy Lamb as part of the permitting process. Next slide. These are just some minimizations, and we've sort of talked about that. Moving the area away from the tidal buffer, moving it away from the resource area. Next slide. These are just some of the written discussion of narrative. You want to write it, you want to have photographs, etc. Next slide. And then these are other things that have to be part of the design. So all this has to be in your narrative. Next slide. I just want to do a quick minimization. This is the kind of thing I do with these engineers. They had a trail, they had all their gravel wetlands, they're next to a valuable wetland. I said, why don't we move the trail? Why don't we tighten up? So we had places where we were right next to the wetland and had like 10 to 20 feet of buffer to the wetland. Next slide. And instead, we now have 25 to 40 feet. This, you have to look at every area. And so you show these plans, and they tightened up everything in the grading, and they now have an important buffer. The green is the 75-foot buffer, but the area closest to the wetland is protected, and that's the most important part of the buffer. Next slide. These are just the 9 additional things that we must do, again, to cover in your narrative. Next slide. These are the last 5. And I know you say commerce, navigation, things like that, but a lot of that has more to do with docks and breakwaters and all kinds of things like that. Next slide. This is it. Questions? Sorry for going over 5 minutes.
Okay, Mark, we'll take some questions now. Are you ready?
I'm ready.
Okay, so are there situations where you would suggest using LiDAR?
I use LiDAR whenever I need to do remote wetland assessment. I just recently used LiDAR on a project that has a lot of abutters concerned, and we were impacting a wetland that had already been impacted. And what I did is I used LiDAR to go back in time and look at what the roads that had previously been constructed had done to the wetland. And I was showing how the wetland was already impacted and culverted. And I used aerial photos and LiDAR. The LiDARs really also show all around where there's houses, the fact that they built up for the septic system in the house. They all look like little pods when you use LiDAR. So yes, I use it for impact assessment. I also use it for arm studies in large scale wetland mapping.
Thank you, Mark. We've used that too. We're currently verifying the draft NWI maps, extremely valuable, used in combination with aerial photos. Timothy Mallett's also put a guide here for living shorelines. He's also has a specific question for you. Could you speak to the importance of an accurate property boundary along the shore in terms of impacts or changes over time?
Yes, we've had a couple cases, and I'll throw out a dune case where the dune is expanding and the high tide line is moving into the ocean, and the owner owns to the high tide line. In Seabrook, there's 4 properties that go to the tide line in this one location, and they're actually gaining land, but they're also gaining a lot of dune height because that dune is totally exposed to the north and east. But yes, this is why wetland boundaries have to be re-examined every 5 years, but tidal boundaries can have even more change. And the way they're talking about sea level rise, it can have a big impact. So yes, property boundaries are critical, especially in cases where they represent portions of of the owner's property.
Okay, we have 2 more questions and then we're going to move on to the next presentation. It says here from Ann Schultz, Mark mentioned seeing evidence of wetland marsh migration over the past 10 years. How about the damage from extreme events? The Little Bay property example, is that recent damage?
That was a combination of storm events and then longer term slope stabilization issues. But yes, and a lot of these seawalls are all storm events. So that March event in 2018 tons of seawall, well, a lot of seawalls were tons of stone was pulled off those walls by specific nor'easters and storm surges. And I have clients who have 3-story houses where spray was going over the house. I have clients who, with wind events, have sand on their 3rd-story deck. This is all part of stronger events.
So last question, then we're going to move on to the next presenter. Any thoughts on using perforated foundation drains in appropriate situations?
That's a little above my pay grade, but and I think it raises an important. Well, we use a lot of stone infiltration trenches, but I would imagine perforated drains may be useful too. But I'm not. We meaning the designs I work with engineers again to do infiltration. We do a lot of that. I do know that where those storm drains come, where those foundation drains come out, often can have a big impact, as I pointed out in that slope in Newington. Sorry for going longer.
Thank you, Mark. Excellent job. So the next, I'd like to introduce the next speaker. Okay. So the next speaker I'm going to introduce is our last speaker of the day. Presenter of the day is Cheryl Bondy. Cheryl Bondy is a mitigation program specialist at the DES Wetlands Bureau, where she assists in the support of the Aquatic Resource Mitigation Program. Before coming to DES, Cheryl held several positions in academia as an instructor and researcher, and also worked as an aquatic biologist for the Forest Service and the California Fish and Game. Cheryl has a PhD in ecosystems ecology from SUNY College of Environmental Science and Forestry, and a master's in aquatic ecology from Humboldt State University in California. Cheryl enjoys cooking, reading, soccer, and exploring local hiking spots with her family. So we're privileged to have Dr. Cheryl Bondy here today, and she will present on compensatory mitigation for impacts to coastal aquatic resources. Thank you, Cheryl.
Okay. Thank you, Marianne. Let me just. All right. Thank you, everyone, for being here today. Good morning. And thank you to all of the speakers that spoke before me. Those were some great presentations, and I feel like they really set the stage for this final topic that I'm going to be speaking about, compensatory mitigation for impacts to aquatic resources. Next slide, please. So I am going to take a little bit of a step back. I'm sure everyone on this webinar knows what compensatory mitigation is, but just to sort of set the stage so we're all starting off on the same page here. I feel like the previous speakers, Eben, Stephanie, Mark, everyone did a great job about talking and stressing the importance of avoiding and minimizing impacts to aquatic resources, especially the vulnerable coastal wetlands and streams. And unfortunately, after avoidance and minimization, there are some projects that will still result in a significant loss of wetlands and streams. And as Mark just went through very well, all those different functions, flood storage, bank stabilization, fish habitat, nutrient retention, with those wetland and stream losses, we also lose those important functions that the wetlands are performing. So the goal of compensatory mitigation is to sustain these very important functions, these valuable functions at the watershed scale over the long term, to offset these losses that have happened in a watershed from projects that have unavoidable impacts. And so there's 4 different mechanisms that can be used to replace and sustain these loss functions. The most common one in New Hampshire is land protection. So this would be protection of a high value aquatic resource. And the key component for land protection is also protecting the upland buffer, a forested upland buffer to maintain the value of that aquatic resource. The second mechanism is restoration. a third is enhancement, and there is a fourth creation, which is not really the preferred method that's used in New Hampshire. Next slide, please. So after a permittee has avoided and minimized to the greatest extent that possible, and it is determined that mitigation is needed, there are then two options for mitigation. There is permittee responsible mitigation and an in lieu fee payment. And I am going to make it easier, and I'm going to refer to permittee responsible as PRM and in lieu fee as ILF, just to kind of shorten it. So for PRM mitigation, the permittee is going to provide a project to offset the loss functions. So the responsibility for the mitigation is completely on the permittee. They are responsible for the design, implementation, monitoring, and the long-term stewardship and success of that mitigation site. And so the impact to compensation ratio is usually a 1-for-1. So there's one impact, and then there's one mitigation site that's going to offset that loss. And that mitigation site may be in the same area as the project, as the impacts, or it might be off-site. And mitigation is usually done at the HUC 10 level, although in New Hampshire, it is first supposed to be looked at the town level. The second option, the ILF payment. I'm sure everyone on this call knows about the Aquatic Resource Mitigation Fund that we have as our ILF program in New Hampshire. For an ILF payment, the responsibility has been shifted away from the permittee now, and the responsibility is now shared between NHDS, whose responsibility it is to find and support projects that are going to offset the loss functions and facilitate their success. I like to highlight facilitate their success because I sometimes think that people think that when the ARM program funds a project, a check is written and that is it. But it is DES's responsibility to ensure that the mitigation succeeds for the long term. And then the grantee is then responsible for the design, implementation, monitoring, and success, but with DES assistance and oversight. So it doesn't just end once the project's in the ground. This is a continued shared responsibility to sustain this mitigation site. So the ratio of impact to compensation is then many to one. So many impacts, the money is all pooled, the ILF payments are pooled into the ARM fund, which will then fund more of like a handful of projects per grant round. So you have many payments that are then going to fund a single larger, more high value site. And as a result, it's off-site mitigation. And this is usually more at the HUC 10 level. Those that are familiar with the ARM program knows that we really do try to gear towards the HUC 10 level, but sometimes no projects are submitted, applications at the HUC 10 level. Next slide, please. So the mitigation thresholds in New Hampshire with the rules update in 2019, some parts did not change, but some parts did. So permanent impacts to freshwater wetlands greater than 10,000 square feet, that is the same as it was previously. Of particular interest to this group and this webinar today, any permanent impacts to the tidal surface waters, tidal wetlands, the tidal buffer zone, or the sand dunes requires mitigation. Now there are project exemptions, which I will discuss in a moment, but from the get-go, those types of projects require mitigation. Major impacts to streams, so new channel and bank impacts greater than 200 linear feet, and tier-specific stream crossings. Docks and shoreline structures greater than 2,000 square feet frontage, that is the same. A new one is any permanent impact to a priority resource area, regardless of the size. And Eben described what a priority resource area is in some good detail. And he showed you the wetlands permitting tool, which is something that can be used as a pre-screening tool to see if your project is in a PRA. And then pond construction greater than 20,000 square feet, that is the same. So I have an image on the right here of the permitting tool, and there's a fact sheet on PRAs that better describe what types of situations classify the project as having a PRA. Next slide, please. So here are those project type exemptions that I mentioned before. So under 605.03b, there is a list of projects that are exempt from mitigation in terms of tidal resources. So maintenance activities that have been classified as a minimum impact, a dredge for existing federal navigation projects, any project that's been classified as a restoration or enhancement project. For the tidal buffer zone, mitigation is not required if it's developed and located greater than 75 feet from a salt marsh. So that's when it's not required. So I guess you could flip that around and say mitigation is required in the tidal buffer zone if it's undeveloped and within 75 feet from a salt marsh. And then upgrading a Tier 4 stream crossing that complies with 90407, so it's not an alternative design, and it improves tidal connectivity, hydraulic capacity, and aquatic organism passage. Those would not require mitigation. And then also if a crossing is considered self-mitigating, that would not be requiring mitigation. I will say that that last bullet there, that is something that would need to be discussed in great detail during your pre-application meeting with your regional wetland specialist. Next slide, please. So here are sort of the project planning and mitigation steps. The very first question is, does your project require mitigation? And that can be a difficult question to ask from the get-go. But at this point in your project, you have already done perhaps the functional assessments, the coastal vulnerability assessments, used the screening tools available to see if your project area is in a PRA. You have searched the NHB database to see if there's any protected and threatened species. You have had a functional assessment performed, and that's when you have all that information, you can start to look at that criteria list that I had on the previous slide as to whether or not it's going to require mitigation. Under the new rules, so if it permanently impacts tidal resources and it's not exempt, that list of exemptions, then it probably does require mitigation. So I would recommend the first step would to be arrange a pre-application meeting. DES has a new webpage, as I'm sure you've all seen, and there is a section on the mitigation page about pre-application meetings, and there is a new guidance worksheet. There's a little image up there in the upper right to show you what's the purpose of a pre-app meeting and what you need to bring to your pre-app meeting to make it productive and efficient and to get the questions that you need answered from that meeting. After you have your pre-application meeting, if it's been determined that mitigation is going to be needed, you then have those two options that I described earlier. But they do come in sequence. The first option is that the permittee needs to evaluate local permittee responsible mitigation first. Local even has two tiers to it. First, there's on-site mitigation. If that is not suitable, then local means town mitigation. So the conservation commissions are responsible for creating a mitigation priority list. We have created some new guidance on this, and Lori and I have done some presentations for Seacoast Conservation Commissions on how to create a nice, diverse mitigation list. So when a project is happening in their town, there is a sort of a menu of projects that could be selected from. So this is on the webpage, and take a look at the types of projects that could be included on those lists. If there's no suitable local mitigation, then the ILF payment to the ARM fund is the choice of mitigation. Next slide, please. So once the money goes into the ARM fund, the payments are pooled by HUC 10 service areas. And then this money is dispersed as competitive grants within the same watershed, within the same HUC 10. And a zoom in of what this looks like in our Salmon Falls Piscataqua watershed, you are seeing in the map, those are every ILF payment that's been made into the ARM program since it first started. And the polygons are the projects that have received ARM funding. And so at the landscape level, at the watershed scale, what you can see is that, the goal is to try to balance and offset the losses with the mitigation sites that are funded. Next slide, please. So wetlands mitigation as it pertains to sea level rise and infrastructure. So how can mitigation be used to address the issues that we've learned about in this two-day webinar about rising sea levels within the context of coastal infrastructure? So despite best management practices and on-site avoidance and minimization measures that are required under the new rules, and all of the detail that Mark West has gotten into of the different types of assessments that are done on the ground during project planning, there are some projects that will result in a loss of coastal resources. And infrastructure projects are often very large and they're often site constrained. And so it might be harder to make some on-site amendments or measures to offset those losses. And so those types of large projects often are the ones that require mitigation. And so I think that this is an opportunity to use the best available science and the practitioners in this state to find and create and maintain the best mitigation sites possible to offset these unavoidable losses and to sustain the coastal functions. So as we saw yesterday, New Hampshire has a great team of scientists doing great research on coastal sea level rise and sea level rise projections. And so we have a great source of data and folks that are doing this work. And so this is an opportunity to use that science to find the best projects that we can. Next. And so what makes a good mitigation project? So back to the goals of compensatory mitigation, we need to find projects that are going to sustain important aquatic resource functions over the long term. So we really want to key in on protecting, restoring, or enhancing high quality aquatic resources. So think back to what Mark West was talking about with his functional assessments, especially in the coast, these really important functions that are vulnerable to sea level rise and climate change. So flood storage, bank stabilization, fish habitat, flood flow attenuation. We also have some more rare, aquatic resources, vernal pools, designated rivers, prime wetlands, and their buffers. Those are vulnerable resources on our landscape, and so those would be highlighted as a good mitigation project and targeting those functions that are important to this watershed. Also, projects that are going to benefit drinking water supply and water quality. So when you're looking at the different screening tools or doing an assessment, look for areas for protection and enhancement that are related to source water and groundwater areas. And I just realized my asterisk on the bottom. I want to point out that when I'm talking about what makes a good mitigation project, I'm talking about both types of mitigation. So a permittee responsible project and a project that could be submitted to the ARM fund for a grant. Because even though there's two different mechanisms to obtaining a mitigation site, mitigation has the same goals. So a permittee responsible site and an ARM funded site should be in alignment, like they both have the same criteria of what makes a good project. Next, please. Also, targeting areas that are important for fish and wildlife. So threatened and endangered species, exemplary communities, rare plant communities. Also addressing future habitat loss and wildlife corridors from sea level rise. So with increasing freshwater or lack of salt marsh migration, where areas that it's predicted that there's going to be habitat loss in the future, perhaps targeting those areas for mitigation to create these refuges on the landscape for future habitat loss scenarios. We have great resources with the Wildlife Action Plan and on the New Hampshire ARM Mapper and also on the Fish and Game webpage is the fisheries habitat layer. So those are great resources at targeting fish and wildlife projects. Next, please. And prioritizing locations that are critical linkages in the landscape to support long-term connectivity for wildlife corridors and conservation focus areas. This is a map showing the conservation parcels in the Great Bay Area. Creating linkages between those parcels is key to creating large unfragmented blocks. Rather than having mitigation dispersed and fragmented, we want to concentrate efforts and build upon pre-existing conservation. Next slide. So those are that's sort of the overall, like, what makes a good mitigation project. In terms of practice, what practices can be done to create a mitigation site, whether it's permittee responsible or an ARM funded project. Projects that are going to remove fill from degraded wetlands, restore hydrology by removing drainage systems, berms, and culverts, and establishing native plantings. So any type of a restoration and enhancement activity can be considered mitigation if it's going to offset those losses that occurred from an impact. Next. In particular, for tidal restoration and enhancement, any project that will improve marsh migration, projects that are going to be addressing rising sea levels and climate change adaptability, projects that are going to increase flood storage or reconnect important migration routes for anadromous fish passage, projects that are going to enhance wildlife and restore nutrient exchange and tidal flushing. So those are the types of projects that would be especially useful and needed in the coast for mitigation sites. Next. And living shorelines as mitigation. So using living shorelines to prevent erosion, to protect, restore, and enhance shoreline habitat for fish and wildlife. Eben got into more detail this morning about this gradation of living shoreline of more soft vegetative components along the gradient to more hard rock components, and the suitability model that's been done, and it's posted on the DES Coastal Program webpage. That's an excellent resource of finding locations that would be suitable for a living shoreline project. Next slide. And removing tidal restrictions and estuary systems. So Kevin, Lucy gave a great presentation yesterday about the Resilient Tidal Crossings project in partnership with the Nature Conservancy. And they also have their data up on the Coastal Viewer to identify what undersized small bridges and culverts are causing barriers to aquatic organism passage and tidal migration and are at risk of flooding from sea level rise. Roads and causeways and removing dams, those all can be candidate mitigation projects. Next. And then stream restoration and enhancement activities can also be used as mitigation. So any project that's going to restore aquatic connectivity, improve wildlife habitat, and increase flood resiliency. Daylighting buried streams, habitat enhancement, so in-stream wood additions, some channel rehabilitation to facilitate fish habitat, reconnecting the stream with its floodplain through riparian plantings. Those are all projects and activities that could be considered for mitigation. Next. So now I'm going to get into some examples of the different types of activities to show what's been done locally in the Seacoast. I am going to show examples from permittee responsible mitigation. I only have one. The rest will be ARM funded projects, but just keep in mind that I'm using this broadly as mitigation are both types. It's an ARM funded mitigation site or a PRM site. So protection of a high value aquatic resource and its upland buffer. Here's a project, PRM, that was protecting 29 acres of land. It had frontage right along the Swampscott River. You can see the blue dot, it clearly connected other conservation parcels. So it was a key linkage in that sort of landscape connectivity effort. It was all tier 1 and tier 2 habitat, so great for fish and wildlife habitat. And it protected the forested buffer, stream frontage, so it provides for bank stabilization, flood storage, flood flow attenuation. So it really nails on some of those important functions that I discussed before. Next. Here's an example of a living shoreline project. I'm sure many people on the call are familiar with the Wagon Hill project in Durham. This site was experiencing shoreline erosion rates of up to 1 foot per year, so there was a significant loss of salt marsh. Next slide. This project received funding from the DES Coastal Program and the ARM program. They were able to backfill and plant 30,000 saltwater plants, use living stone to reduce the wave energy and protect the living shoreline. This was a project with it had a large partnership with UNH, the coastal program, the town of Durham. So that is one example of a project that was an ARM-funded mitigation living shoreline. Next. There's also Cuts Cove in Portsmouth, also partnership with UNH and the town, the coastal program. The shoreline was filled and armored with riprap up to about 12 feet above the high tide mark. Next slide. With ARM funds and coastal program support, they were able to remove 200 feet of that hard armoring and create a 6,000 square foot intertidal salt marsh. There was also plantings done in the tidal buffer zone to allow for marsh migration with sea level rise, and there was mudflat enhancement with shell mounds. I should have put a picture. There's some cool pictures of gulls and other birds using those shell mounds for foraging, so it's pretty neat. Next, please. Another project, an ARM-funded mitigation project, was the Lubberland Creek tidal crossing in Newmarket. I'm sure many people have heard about this project, partnership with the coastal program and TNC. This was an undersized pipe that was a complete barrier to fish passage and also tidal flushing from the Great Bay. So as you can see on the map there, this was the first barrier from the Great Bay up Lubberland Creek. This was also a significant flood hazard, causing severe erosion, and it was overtopping and costing the town a lot of resources to maintain after storm events. Next, please. So this project went in the ground in 2019. They installed an embedded box culvert, I think 16 or 18 feet wide with stream simulation. This will accommodate flows for a 100-year flood with sea level rise projections. It has now reconnected the tidal flows to the upstream wetlands. And a very exciting part of this project is that the eel migrations are now back. Before, the eel were unable to make it through that perched culvert, and they are now doing fish monitoring, UNH and the Nature Conservancy, and they are seeing eels there just in the past 2 seasons after this new culvert installed. Next. This is an example from way up in Colebrook, the Connecticut River, but it could be applied to the coast as well. Replanting old agricultural fields to increase the riparian buffer to 50, but preferably 100 feet. So this project, you can see, I love these pictures too. As Mark West said, aerial photos just really tell the story so much better. You can see the photo on the left. The hayfield was being mowed almost right up to the edge of the river. This is just 1 year post, restoration, where they've stopped mowing and have started to do the plantings. That photo on the right. This is just 1 year after. They planted, I can't even remember, like 2,000 silver maple trees at the whole property. So we'll get to see how this site progresses over time. The top, they completely retired that second hayfield, and you can see 1 year post restoration how that's growing in, and that'll be some nice floodplain forest habitat there. Next slide. Dam removals can be used as mitigation. I understand these are very expensive projects that require a lot of partners, but they can be considered as mitigation. So here's an example of the Great Exeter Dam removal. This was the lowest dam on a major tributary to the Great Bay. It was a barrier to anadromous fish migrations. Next page. So this was a large partnership. You can see the partners in the right-hand corner there, the coastal program, NOAA, Fish and Game, and then the ARM provided a small amount of funding compared to how much this project cost. But this project with the dam removal was able to reconnect 15 miles of the Exeter River and the tributaries upstream of where this dam was. And it restored 5 miles of an upstream impoundment back to a free-flowing stream system. The picture in the lower right, you can't really see it too clearly, but all those little black things in the water, those are the herring that are now able to make it up the stream during their migrations. Next. And daylighting buried streams and reconnecting those streams to their floodplain wetlands is always a great mitigation project. This is a project in Dover by the UNH Stormwater Center in the city of Dover. About 1,000 feet of channel that was underground was restored back to an open stream channel. They also restored 2.5 acres and protected these wetlands in the headwaters of the Cocheco River. Next slide. And upgrading and removing old forestry crossings also can be used for mitigation. Next slide. Enhancing fish passage through downstream grade controls. Sometimes a culvert cannot be completely replaced. And in this case, this was for brook trout passage. So not really a coastal example, but this could also be done to facilitate anadromous fish passage as well, using downstream grade controls to reduce a perch. And so here's a case where doing some step pool creation just downstream of the culvert outlet, they were able to regain 1 mile of upstream cold water habitat for brook trout spawning. Next slide. So on that note, I think I'm hitting a half an hour. I have 2 slides left. We do have a 2021 ARM Fund grant round for the Seacoast only. The other watersheds, the ARM Fund is not soliciting for proposals. So for the Salmon Falls, there's $2 million that is available for protection, restoration, and enhancement. What impacts generated these funds? So the money that's been pooled together from the previous year. So in 2020, there were 8 permits in the Salmon Falls watershed that used ILF as their mitigation option. These 8 projects resulted in 10.8 acres of wetland loss. So this included forested wetlands, emergent scrub shrub, and 100 linear feet of stream impacts. The functions that have been lost are wildlife habitat, water quality, flood storage, and fisheries habitat. So as you think about projects, keep in mind that those are the functions that the program needs to target and prioritize to replace and to offset. Next slide. So there's a new DES webpage that I'm sure many of you have seen. The mitigation program just launched the new webpage last Friday. So if you go onto the DES webpage and go to mitigation, you will see that this 2021 grant round has been announced. The schedule is up. Pre-proposals are due May 28th, and the final proposals are due at the end of August. That's the typical ARM grant schedule. Next. And so I want to thank everyone for being here today and thank all the speakers. I think this has been a great webinar, and thanks for the opportunity to talk about the mitigation program. The mitigation program is it is 2 people. It is Lori Summer and myself. So please reach out to us and contact us anytime with questions, or if there's interest in applying for the 2021 ARM grant round, I'm happy to talk about potential projects with anyone. And please visit the new DES website because we have put up a lot of new information on the ARM grant and mitigation in general on there. Thank you.
Thank you, Cheryl. A great job today. We have some questions for you. One question is, how many coastal towns in New Hampshire currently have mitigation priority lists? I don't think we know the answer to that. Do you know that, Cheryl?
We do not have the answer to that. We don't have, conservation commissions aren't like required to submit their list to us and have them on file. I will say that in the past 4 years, Lori and I have done several outreach events. One was in Hampton to provide information and the training to the conservation commissions on how to create their list. And so but I don't know how many have them. That's a great question.
Yes, excellent question. So another question from DOT. which I've reached out to the reviewers of DOT projects, is would you agree that predominant coastal infrastructure projects in New Hampshire tend to be retrofits or focused upgrades rather than large corridor impacts? And I've reached out to Carl Benedict and to Dave Price and Evan Lewis, and yes, all agree that that's true. The last big new corridor project that the DES staff can think of is the Newington-Dover Spalding Turnpike. And it sounds like DOT is developing plans to incorporate sea level rise for replacement of bridges between Hampton, Seabrook, Route 1, and Rye, Newcastle. So I think that answers your question on that. We have another question. Any thoughts specific to linear transportation projects versus other development? I know you alluded to the constraints of mitigation in projects early in the presentation. So I can answer that as well. So looking through the mitigation rules on tidal projects, it does provide under Env-Wt 60504 that on-site mitigation shall be performed wherever practicable. And the department rules define practicable means referencing the federal rule, available, capable of being done after taking into consideration cost, existing technology, and logistics in light of overall project purposes. So I think that a lot of the theme that you've heard today and throughout the training talks about self-mitigating designs. And if you look through all the details of the rules related to tidal mitigation, it does provide opportunities for exemptions based on the design, such as increasing hydraulic capacity, aquatic organism passage. We heard about that yesterday and how studies showed that when aquatic organism passage was achieved, so was hydraulic capacity. A geomorphic compatibility associated with tidal crossings. We heard about that as well. And Cheryl did a presentation showing an ARM-funded project on living shoreline project. And those would not require mitigation if you're doing those types of projects. So I think that that answers that question, I believe. That is a huge question. Another question here is, how common is permittee responsible mitigation versus in lieu fee? And I think, Cheryl, you can answer that, right?
I'm sorry, I'm smiling. That is an excellent question. At the moment, that's something that the mitigation program is working towards enhancing our database to better track that, because currently we don't have the ability to quickly query and get that number. I will say that before 2011, so the ARM program was officially established in the federal instrument in 2012. It did exist in New Hampshire rule before then, so it was used, but not quite as used as it is now. So before 2011, I would say that there is about 650 permittee responsible mitigation projects. After 2011, we don't know what the number is yet. It is significantly less. But I do know that since 2012, since the establishment of the program, there has been 142 payments into the ILF program. So that's over, what, 8 years? So permittee responsible might be, it'll be significantly less post 2012.
Yep.
Sorry, I'm all over the place with the numbers, but
that's all right. I think you've yeah, I think you've answered that well. I just wanted to follow up on what Cheryl said. So part of this training today was funded through an EPA Wetland Program Development grant. Another part of that grant is the department will be looking at, when we have been meeting regularly and identifying ways to clarify how we track impacts, either through self-mitigating on site, through mitigation, and looking at the resource impact versus the permanent impact. And it is a challenging discussion. As you heard from Mark West, there's a diverse array of coastal resources that the department regulates, and how to quantify and tease those out when sometimes there may be overlapping impacts and overlapping resources. So I think that's all the questions we have. Thank you, Cheryl, and I'll just provide my closing remarks. So I wanted to thank everyone for participating today. I hope that you found this to be worthwhile. I want to thank the speakers. We had the 2-day session of a robust lineup of speakers from UNH, the private sector, from the coastal program to DES, and from a private consultant as well today. So it's hard for all of us in this remote setting without the personal engagement to see your gestures on your face, to see your eye contact, if people are connecting and understanding what we're saying. So that does make it challenging in the little box here where we are to understand whether there is connectivity and connection between what we're presenting and the relative feedback. But I felt that the training today was very helpful and built on the science that was presented yesterday. I thought Evan Lewis did a great job covering a robust topic in a short period of time over all the coastal rules and focusing on coastal bank stabilization, the tools that are available. I thought Steph Giolongo also did a wonderful job looking at key takeaways on the steps and the best ways to do a good and complete vulnerability assessment. I also thought that Mark West did a great job on talking about the significance of coastal functional assessment, including narratives, description, aerial photography, key features that are needed to ensure that you can get a complete coastal functional assessment of the many diverse types of resources you'll find in New Hampshire seacoast, and also provided some great examples. And lastly, Dr. Cheryl Bondi provided a wonderful overview in clarifying the difference between PRM, ILF, the ARM fund, what is the key to making an excellent ARM fund project, and examples of projects that have been funded and implemented in New Hampshire seacoast. So the slides today are available as download. And a link to this recording will be posted to our website after they've gone through ADA compliance review. The recording will have an auto transcript generated by the software. DES will send an email to all of the participants when these resources are available on our website. When you exit the meeting today, please take a few minutes to fill out the survey to help us know what worked and what didn't, and provide any constructive feedback. We know that we can always do better and appreciate and take to heart the comments that you will make. I want to say a final thank you to EPA for providing the support for this training. And thank you all for participating. I hope you found this worthwhile. Thank you. Have a great day. Take care.